As engineers, it's important we know what's going on behind the panel. Anybody can pump water, but when stuff goes bad, it really helps out to know what's happening behind the panel. Let's take a look at a diagram I had made, and I'll talk about what's going on with the plumbing and whatnot. So this diagram we had made is just kind of a general overview of the plumbing in your average fire engine. It's not specific to one apparatus. Your plumbing size, flow rates, and terminology might be slightly different. So the pump sits here in the middle. Blue is intake, red is discharge. So we're going to start on the intake side and we'll work our way around. So starting off, there's only two ways you can get water into a fire engine. Either through our master intake, whether it's pressurized water supply or drafting, or from our onboard water tank. So you notice our master intake valve right here by our master intake. The drain valve is on the outboard side of the actual valve. That allows us to purge water, air, debris out of the line so we don't take some foreign objects into the intake. Moving up to the tank here. So all the tanks, when you open the lid up on top of the rig, you see that big tube. Well, that's your overflow tube, right? If we fill the tank up too far, it's going to spill over into that 6 to 8 inch overflow tube, and it's going to spill onto the ground. You see these dashed lines. So the dashed lines represent baffles. Almost all of our tanks have baffles in them. And the baffles are there for that live load as we're driving down the road, hitting the brakes, hitting the gas, to keep that water from sloshing back and forth. That being said, if we're driving around town, we should not have our tanks 50% depleted. We should either have them 100% full or 100% empty. Once you get the water level down about halfway, that sloshing is going to be quite a bit more. So keep them full, keep them empty. We'll try to limit that live load. Sliding down here on the intake. So the tank to pump line, the line that goes from the tank to the pump, has a clapper valve in it. So the clapper valve is to prevent pressurized water sources from turning your tank lid into a geyser. Right? If we have pressure coming in here, it's going to shut that clapper valve and not permit that pressure to overflow your tank. Moving down from there is our tank to pump valve. So it's good to note, it says here 500 GPM minimum. That tank to pump line can only flow so much water. NFPA says we need to have at least 500 GPM flowing through that line. Some of them flow more. It's good to know what yours flows. And you'll find that data on your pump test documents, your annual pump test. So if we can only flow 500 gallons a minute through here, we're not going to be able to flow a large deck gun off of our tank. We just won't be able to get the water from here to here. So that's a good number to know. Moving around to the discharge side. First thing off of our discharge is this tank fill line. And that tank fill line can be anywhere from 1 inch to 2 inches in diameter. Tank fill just takes water off the discharge side of the pump, comes up, dumps it right back into the tank. So that tank fill line can circulate anywhere from 0 to 400 gallons a minute. I've seen up to 450. It depends on your pump pressure, how high your discharge pressure is. But that's quite a bit of water. It also allows us to recirculate water, right? If we're not flowing water out of nozzles, we can just sit there and circulate water and keep our pump cool. Good to know that tank fill on our poly tanks that we have in our rigs, you don't want to fill your tank at over 100 PSI. It's written on the side of almost all the tanks. So we don't want to have this wide open if our pump pressure is way up in the 180 range. Just something to keep in mind. Moving over, we have our pump cooler, or it's also called a recirc line. It comes off the discharge side, just like the tank fill, dumps right back into the tank. That's going to be a smaller line. It's going to be a 1/4 inch to maybe 5/8 of an inch. And its purpose in life is to circulate 60 to 90 gallons a minute. It's just enough water to keep our pump cool if we're not actively flowing. Moving down, you see a 2.5 discharge down here. Now that's not just a 2.5 discharge. That drawing just represents all the discharges, right, except the foam ones. So off the discharge side, we have 1.5 inch discharges, 4-inch, deck guns, hose reels. All right, so that just kind of represents just our standard discharge. Moving down from there, off the discharge side of the pump, we have foam discharges. If you have an onboard foam system, they're very unique in how they're plumbed. You notice in this drawing there's 3 foam discharges, and they're all fed off of one pipe. That pipe has a foam proportioner, which squirts the foam in, a flow meter, which tells the proportioner how much foam to squirt in for how much water we're flowing, and a clapper valve. The clapper valve is going to prevent water from coming back into that discharge manifold and contaminating everything else with foam, like our tank and our other discharges. Good to know. In this drawing, if we have 3 foam discharges, how much water can we get out of those? Can I hook a 2.5 up to each one at 350 GPM? Well, depending on your rig, probably not. Most of them are fed by a 2.5 or 3-inch pipe. You're going to max out at about 750 gallons a minute. It's good to know for your rig what the specification is for your foam manifold. How many foam discharges can I flow at once, and at what GPM? Moving down, we have our engine cooler valve. So this is going to run a pipe up into the radiator. It's going to be a heat exchanger and allow us to run pump water through the radiator and come back into the intake of the pump. So if it's in the middle of summer or the engine's working hard and we notice the coolant temperature is getting too hot, engine cooler can be engaged and circulate cool pump water through the radiator, keeping our pump cool. So one more item we need to talk about is the primer motor and primer system. The primer is going to come off of the top of the intake to ground. There's going to be a primer control valve and a primer motor. When we pull that primer control valve, the primer motor is going to lower the pressure inside of the pump, allowing atmospheric pressure to push the water from the tank into the pump or push the water from our static water source up into the pump. One thing to note, you do not want to actuate that primer if we're hooked to a pressurized water source. It'll cause damage to the primer control valve. As you can see, there's a lot going on behind the pump panel. A good functional understanding of the mechanics of what's happening is going to help you develop as a good engineer. Along with this video, there's a worksheet that's going to come with it. There'll be a series of questions just to get you familiar with your apparatus. Tank size, tank to pump flow rate, some questions on foam systems. Sit down with your crew, take a few minutes, try to generate some conversation, and just learn a little bit about your apparatus.